All right, hello back, hello and welcome. In this video, we'll be looking into gradient of curves. As I said before, differentiation in a nutshell is to calculate the rate of change, or rather the gradient of a curve at a certain x value. So here we've got a quadratic and we got this quadratic x square here, and the x values are given to us as a table, and we have to guess what is the gradient of each of these coordinates, a gradient of the tangent line at each of these coordinates. So just like on the left here, we got y equals to 3x plus 2. The equation of the line is telling us the gradient is 3, all right? So here, just imagine that you are going to work out the gradient. What do you need to do is you need to draw yourself a right angle triangle somehow or another and try to guess what's the change in height divided by change in base. Okay, so I'm going to have a guess that this minus 3 is going to have gradient minus 6. Let's see. Oh, wow, I'm a good guesser. So minus 2 is going to have a negative of minus 1 here. And I'm guessing this one at this point where x is minus 1, the gradient is minus 2. And next one gradient is 0, and it's 2 and 4 and 6. Now I had some lucky guesses here, but I wasn't just guessing. I know something that helps me calculate these in my head. All right, so that was just a little trick question. So actually there is, like, if once you've learned by the end of this chapter what's how to differentiate a function, differentiation of x square is going to have give me a different function that I can substitute these x values into it and get my gradient. So in my head I just knew some other function which usually written as f dash. Okay, so if you differentiate f of x, sorry, this is just the original function f of x, and when you differentiate it, you write that differential function as f dash. All right, so it's also called the derivative function. All right, so I'm not going to reveal that function to you now just yet. Alright, so the first exercise, I hope you do this with me. This is not just the cinema, not watch and go. So do this last part at least with me. So the the point of is to draw these blue lines here. This curve, this is a curve of y equals x square, and we are drawing these secant lines. This secant means that one end of the line is on the curve, and the other one is at A, and we are sliding that point P from up there down further. So first P was up here, and then we sliding it down, and we are measuring these gradients. So first the coordinate of P was at 2 and 4. So we saying now calculate uh, what's the gradient of that line uh, at that point. So what you say what's the difference in coordinate of A, by the way, is uh, 1 1. That's fixed. So you say what's the change of y value and divide by change of x value, and if we put those values into the gradient calculator, you get 3. And then for the next point where you slide it further down, the difference between 2.25 and so on is are these values. These are just the gradients that are coming up here. Gradient of those blue lines. Secant lines means that, yeah, I told you. And what we're trying to get to is finally the gradient of that red line, the tangent line there at point A. Notice the tangent line only touches the curve at point A. So far we've slid it down all the way very close to point A. Okay, so we almost touching point A here, but this secant line is not uh, like visible because I cannot draw it with this pen, but it's very close to this at this point here where x coordinate is only 1% of the unit away from A. It's almost non-visible by eye, but it does have a gradient. Its gradient is 2.01, and notice, look at these values. They kind of converging towards the number, okay, our final value here. Converging means they're approaching what we want it to be. So now for part 5, I'm going to do this with algebra, okay? I'm writing this limit notation here, limit of h approaching 0. Limit means that as h approaches 0, what's happening here? H is just some distance away in x direction from point 1, okay? So when we have that, that means that we have uh, h 1 plus h is squared because the function is x squared, so that's the change in y's. This is just 1 square, which is still 1. Alright, so if we expand the numerator there, we're gonna get this answer here, h squared plus 2h plus 1 minus 1, and so on. And in the denominator, this point minus the original means this 1 and that minus 1 cancel, and over here we've got these two ones cancelled. So after all these cancellations, if we write what we have there, we have this fraction. Still we can factorize the top, and what we noticed is that we can factor h out of that and we get h plus 2 inside the bracket, and this h in the denominator cancels that h. Now this limit now is there because we couldn't earlier divide by like this 0. We couldn't substitute here because we had a h in the denominator, and in the maths we're not allowed to divide by 0. But now that the h is gone, that h cancelled away, we left with this expression where limit of h naught, h going towards naught, is h plus 2. Now in this expression, we are allowed to kind of substitute that and think h is approach 0 now, and we remain with a 2. So the gradient function is 2. Well, the gradient at point 1 is 2. Alright, sorry, this is not a function, this is still just the gradient at point A. Alright, so what does that tell us? At that point, this gradient of the tangent line is 2. Alright, you might think, wow, all this work, what's the big deal? Alright, so this is just to get you used to the idea of how to actually, what we're doing here is we're still using this formula where the gradient is y, change in y divided by change in x. Alright, so that's the point to remember. We're using algebra here, and we're substituting algebraic values rather than coordinates there. Alright, so hope you found this helpful. What the comment for part C is that is part C is asking us comment on the relationship between your answer and to part A and B. So calculate the gradient of the tangent. So here T. So we were supposed to do the part A with the triangle ourselves, draw a triangle. You would have found the exact value is actually 2, and this answer that we got with algebra in part 5, this is the challenging part, most challenging part of the question, that if you're not familiar with limits and you don't know what's going on, this is hard to understand. You would just substitute h equals to naught at the end after the cancellation. So part C is saying comment on the answer, and the answer is that as h tends towards 0, the gradient of the secant line approaches the exact value of the gradient of the tangent line at point A. Alright, secant lines were those blue lines that we calculated in part B, and tangent gradient of tangent we would have found in part A to be exactly 2. Okay, so approaching these values we said are approaching. approaching. Okay, this is the definition of limit. All right, so have a go at this exercise, and particularly question 3 and 4. I would recommend you have a go at part 5 of each of these questions. They both have the same function, y equals x squared. So you're practicing the same thing over and over. Maybe it will help you. Infinitesimally small. If you hear that word, it means gradually tending towards zero, small, getting smaller and smaller values. All right. So I'll see you in the next video.